Thanks, Rich. Hi, everyone. My name is Matthew Iannucci. I work for RPS Group in the Ocean Science division. And today I'm going to talk about some of the work we've been doing with IOOS to make model data in the cloud more accessible. Jonathan Joyce is also here, and we've been working to push this project forward technically for quite a while now. And I'll start by giving a quick overview of a little bit about what IOOS is and what the Reaching for the Clouds project is that we've been working on for the last few years. So in 2021, we started working on a project that we've dubbed, I don't know if we dubbed it or IOOS dubbed it, Reaching for the Clouds, with the goal of increasing the use of IOOS model data, or IOOS data in general, not just model data, using the cloud, and how we can improve workflows for users that want to work with data that's available to them or they might not know is available to them. So over the past 3 years, we've been working to understand what the current state of cloud workflows is for this type of data for ocean forecasting and observation data. And we've been developing prototypes and architectures to tackle some of the problems that we've come across as data management. We work in data management for IOOS and other regional associations to provide observation and model data for ocean environments to users. And we've been working to develop prototypes that address specific problems that we've come across, but also problems that users we've talked to and stakeholders have brought up or been frustrated with as they try to move their organizations forward. With that, I think we started out early on. It's a big problem space. There's a lot of different data problems that one could choose to address. And for us, we met together with a bunch of members in the community early on, and one of the common threads that kept coming up was the difficulty of working with model data, and specifically, the challenges around working with different. How model data is often very different, and it's very inefficient to work with cloud model data as there's different formats for different models and different grids for different models. So there's a lot of opportunity for improvement there. And we wanted to see what we could do with the cloud to push that forward. So with that, to set the stage, we currently operate an IOOS project called the IOOS Model Viewer, which is a web portal for viewing oceanographic model data, oceanographic and meteorological, I guess you could say, model data in a web mapping platform. It also exposes the data through a thread service for users to download the data directly as they would like to use it. And so if we take stock of what we're doing currently, as we've been working to move that system towards the cloud, and that predates my time at RPS in the last 3 years. So it's been a long push there. So currently, the way that system works operationally is there is an S3 bucket where the data lives, but that data has to be ingested from sources that are not in the cloud. This includes nomads. This includes co-ops, which is I don't know what you call it inside of NOAA. Co-ops it's the operational. I forget what co-op stands for, but they produce tide observations, tidal modeling, currents, winds, all the oceanographic modeling you could think of, and they have their own threads. So we're ingesting from their thread service, and then beyond that, there's research partners at universities, there's other research partners in the industry, and we're running cloud workflows to go out, download that data, and move it into an S3 bucket that we control. And now to get that to work with threads currently, we have to basically use a file system mount and then on that same server, point threads at it. And then we also have NCWMS2 on top of threads to provide web mapping services. And so this works, but it doesn't work well for us. Specifically, threads is not really, we found that it's very expensive to run in this workflow because threads does a lot of reading and listing, and it's not only taking what it needs from the cloud, so your build every time it does something. The other issues that we have are, we're serving up 300 plus, data sets through threads, and threads pretty much, for us anyways, we found that it scales vertically, not horizontally. So what I mean by that is we can't just spin up more threads without increasing our operational costs. So we have to just scale our thread servers up to make to be able to serve the data performantly as we would like. And we've also ran into issues where we have problems with threads not being able to read the data formats of some ocean modeling data sets. So different grids, different time extents, those kinds of problems. For NCWMS, we have the same vertical scaling problems. It's built on, heavy caching and indexing, and it's very hard to extend. As new models come up, they may not work right away. And then there's a long feedback loop with the developers of that to get those models supported. And for the ingestion, we've been working, and a lot of data sets that we're working with specifically for IOOS are available in NOD now, the NOAA Open Data Dissemination Program, which was the old NOAA Big Data Project. And so those files have free egress for users, and for NOAA too. So for us, we want to be able to leverage that as much as possible. We're not event driven. So when new files were added to nomads or the co-op threads, we had to go out and get it. We had to just kind of poll until that was there. There was no real way to be alerted when there was a new event of a file being uploaded. And lastly, data duplication is expensive. We've looked at the cost of moving only to ingest data that isn't on NOD, and it cuts down our cost by 80% for cloud storage. So we started thinking, what capabilities does our existing stack provide? And if we were to prototype a system for the cloud, what would that look like? And so for ingestion, the most important thing is that we need to preserve data in its original format. That means no regridding, no subsetting. So it would just be the files as they were distributed, so that when scientists or the public are getting that data, they know it's the data that's coming from NOAA. Threads provides us many things, catalog services being one of the biggest ones, aggregation. So I'll get into this more later, but the forecast model run collections that give you a view into a model run or the best time series over a given time period, very powerful. OpenDAP, so that users can get that data as they need it on demand. And then for NCWMS2, we as in RPS are specifically relying on WMS services, right? NCWMS2, but others can also leverage those services. So we started thinking about how, what do we want to build with this prototype? How can we take advantage of the benefits of the cloud? We want to look into how we can save costs, how we can make things more collaborative, work with the general Pangeo community and beyond to kind of push these services forward. We want higher availability. We've had tons of issues with keeping threads and NCWMS highly available, to say the least. And then global infrastructure. We have a lot of models that come from research partners in the West. We have models from research partners in the East. Is there a better way to ingest data, a better way to make data that's regionally important available faster? And then how do we cloud optimize the data so that it's ready for researchers and users to use it when they want it, and make that as fast and performant and lower the barrier to entry for them to use it. So we decided one of our prototypes would be to build a cloud optimized data management system specifically for IOOS model data. And when I say that, we're going to focus directly on NOS, like operational forecast system models, to keep the scopes as small as we can to start. And so our goal is, enable better access from what people are using to do data analysis these days with Jupyter Notebooks, Xarray, Zarr, all the good stuff that we talk about in the Pangeo meetings. How do we get more performant data access for both consumers and providers? So that's not just users grabbing that data from a notebook, but it's also companies like RPS who are serving that data through web mapping applications and other types of applications. How do we build a more extensible service layer, a platform to build services that people who don't know how to use notebooks can still get the data that they would want? Users that can't code can still get the data that they would want. And then how can we be resilient and scale horizontally as fast as we can? So the ingestion system is pretty straightforward, but it works very well. So the idea here is that NOAA is getting data ingested from nomads operationally or from co-ops in their other non-operational buckets, but we're relying on the operational one for now. So that's the last 30 days of data. That data gets uploaded into the S3 bucket on NOD. An SNS notification goes out, and we have queues running that trigger a Lambda that basically just uses Kerchunk to generate Zarr representations of NetCDF operational forecast system or operational forecast system model data with directly in the cloud. That gets uploaded to another cloud bucket right now that's living in an IOOS cloud bucket, but in the future we want to move that somewhere else. So the translation is we're just taking the NetCDF file that comes in, indexing it with Kerchunk, and then spitting out the Zarr virtual representation of it in another bucket with just the .zarr postfix to the end. This is really similar to the way GRIB, if you're familiar with GRIB data, GRIB for a lot of models and forecasts, they have a sidecar file with IDX file that exports the byte offsets of all the messages inside of a GRIB file. And this is doing the same idea where we just want to have a little sidecar file that lets you load every given model data file with Zarr. And then the next part is Threads provides these aggregations. For those who aren't familiar with the way Threads does aggregations, I don't want to get too deep into it, but it provides this view into your best time series where you get a virtual data set of if you have 20 model runs spanning 20 days, it'll take the best representation from those 20 model runs to create one aggregated data set where there's one output at each time step over those 20 days. And so we want to be able to aggregate on time dimension these Zarr sidecar files that we are spitting out. And so we can do this with the same kind of workflow that we just showed. I just want to give a quick shout out to Xarray FMRC, which is a work in progress that Alex Kearney is working on to be able to do some of this stuff lazily. We're choosing right now to not do it lazily because we want to be able to provide these aggregations to users to use without having to go through any other kind of systems. But for now, but that's a good project to look into to learn more about this. So the workflow here is it's very similar to the previous slides I showed, where we see that a new Zarr metadata file has hit a bucket, and then that triggers another Lambda that will compute our model run and forecast model run collection virtual Zarr aggregations. And then those will be uploaded into the same bucket with different naming. And so for one file, if we say Delaware Bay forecast has been uploaded, that gets kerchunked into this Zarr representation. And then from there, we can spit out the model, we can update the model run aggregation. So every run in that T0Z model run and the best forecast aggregation. So that's every model run over the last, in our case, it's going to be the last 30 days. And you can see those sizes are pretty small, but 3.2 megabytes is getting up there. But that's pretty much the bounds of how deep we're going to be going. And so once these are generated, we can, I'm sure most people here are familiar with Kerchunk, so I don't want to go too deep into that. But we can just load these directly from S3, and then we get our full best time series. So we get a full data set here where we're aggregated over 528 time steps for this entire model, all the model data that we have from this one model at any given time. We also need to provide services. And so for this, we starting at we had a IOOS hackathon, I think it was April 2022, or is it 20? I think it was 2022, where we started working with Xpublish to see if we could provide some of the services that we were relying on using Xpublish for some of the gridded data that we found cumbersome. And we really liked the API, and it turned out like it worked pretty well. So we started building on top of that. A little background on Xpublish for those who don't know. Xpublish was originally built to publish X-ray data sets to the web by providing, basically a virtual Zarr hierarchy over HTTP. It's built directly on Fast API, so anything you can do with Fast API, you can do with Xpublish, which makes it really powerful to build things on top of. And since that time, a year and a half ago, Alex Kearney has been working deeply to kind of create this new pluggable, extendable core for the code base, so we can build like really powerful APIs and plugins to create these custom experiences built around X-ray data sets or beyond. The idea being that like we all have different needs with this. We all have different like end user needs, but we all want to use like this same really powerful X-ray Pangeo type stack to do things, because it makes it really fast to build these customized experiences. So currently, some of the prototype plugins that have been built out are the OpenDAP, OGC EDR, OGC WMS. And then there are some working with how to load in different catalogs, how to load in intake directly into it. So it could just work. It will just work if you specify an intake file to run with, those types of things. There's a Xpublish community if anybody's interested in getting involved and learning more. We found it to be really awesome so far. And so for us, one of our core products is called Oceans Map, which is I said before, it's to make it simple, is a web map viewer, which is used for the IOOS model viewer to view model data and forecast data and observations from all types of data sources directly on a web map. And we rely heavily on WMS services right now because we have too many data sets in this IOOS model viewer to like pre-compute all our tiles and visualizations. So everything's done on the fly. And so the reason why we need to build a WMS system instead of just using something that exists already, like Tyler, is because we have very bizarre and not fun grids to work with that we have to make sure work. And back when we started working on this, probably a year or 6 months ago, Tyler didn't support the types of customization that we needed for the grids. I'd love to revisit that in the future if that changes. But for now, we have to support, for these NOS, National Ocean Service models, we have to support curvilinear grids, all types of unstructured grids. They're all slightly different. And then we need to be able to create an API where users can kind of customize the behavior, because there's always even if we cover the basics with these, there's always going to be other models that are the same but slightly different. Delaware Bay, the Delaware Bay model is the same as the Chesapeake Bay model, but they are different. If you want to try and plot them, they will not look good if you do them the same way. It's little intricacies like that that become very annoying. And so you want to be able to like override default behavior as new models become available and as new models pop up. And so for us, the service of this are the NCWMS2 compatible APIs. That's what we're building to support, which is get capabilities, get feature info for, which is the same thing as get time series, basically, where you can just click on a point and get a time series. Get metadata to just get the metadata of an area. And then we're building on top of Data Shader, which has been really great. It's really fast. And we're still pretty unoptimized. So it's been pretty great so far. So then from there, having a WMS plugin, we kind of built this little prototype server just to like prove out the viability and see if we provided this data, into our workflows now, if it works the same or better than the products that we're using now. So we built the XREDS, which is X-ray environmental data server, to try and just prototype this up and see the results of, can this cloud optimized workflow match what we're doing now? And so with this kind of package around Xpublish, we're automatically inserting certain plugins with OpenDAP, EDR, WMS, and we're doing a custom dataset loading plugin that will load our Kerchunk datasets directly from our S3 stores. So these best time series aggregations, so we can serve up the same thing Threads would. We have it Dockerized, running in a Kubernetes pod behind a load balancer, and it's been pretty stable. And when it's not, it pops right back up alive instead of NCWMS taking 30 minutes to reindex all of its data, which is really nice. We're missing some things. We don't have like a user interface like Threads does for OpenDAP queries or for the catalog. We want to build that, but we have not done that yet. And then optimization. This is all pretty much running unoptimized. It does crash. You can see there's a lot of variables in that screenshot that probably shouldn't be shown there. It's very much a proof of concept, but if you want to take a look, there's a GitHub link down there. And then there's a prototype running with a subset of the models that we've been working with so far. Yeah. And so what's next? We're working with Nod right now to get our virtual Zarr sidecar files pushed into a bucket for public consumption. So hopefully everyone can use those without worrying about egress, or they'll be the same as basically the same as being able to read in the current data that's available on Nod, but you'll be able to do it with a Zarr workflow, which is really great. We have to build out, observability and all those things into our pipelines before this all goes operational. And then we have to expand our ingestion. Currently, we're ingesting all the ROMs models and the Northern Gulf of Mexico model. And we have a bunch of more National Ocean Service models to scale out to. We want to look into lazy aggregations and stack catalogs too, to see how we can provide those, whether that's through Xpublish or if we should be building those into our pipelines as well. We want to optimize our Xpublish services. Currently, Xarray and Dask and the whole state of async data in Xarray is really tough to work with. So we dig deeper into that and see how we can provide a more performant user experience. And then lastly, expand WMS grid support. Currently working on getting FVCOM data sets to work the same as ROMs, and then there's more grids after that we have to support, like AdCirc. So currently working on expanding that WMS grid support as well. A lot of the project documentation that we've been working on is available on GitHub directly at that NextGen DMAC repo. So feel free to take a look around there and chime in if you have any questions or whatever. We're happy. It's an open space. We're happy to talk about it. I think that's all I have.
Live demo?
Oh, you want a live? I can give a live demo.
Yeah, sure. Come on.
Give me a sec. Sorry, I'm lost in space.
It's okay. You're no longer sharing, but I that's probably intentional, right?
What? See if it shares now. All right. Can you see? Everybody can see this, yeah.
Yeah.
So here's our little X-ray environmental data server that we've been working on. There's a couple stubs in here. Like these are stubs to go look at the OpenDAP representation and view instructions for how to open the data in a Jupyter notebook. We have not built those yet. But here you'll see all the models that we have currently available. We support simple ones like the simple like GFS. We can do a get times. We can just do a get feature info to get the data here. But more importantly, we can look at the National Ocean Service ones that we have. So if we look at Delaware Bay, we can look at the free surface, and it's pretty performant. You can see here we have a lot of times. This is the full 30-day aggregation here. This is not built for heavy usability. It's just to view what we have basically. So if we switch, we can see that the time to load new data sets is actually to load new time steps is pretty fast compared to what we've been used to with threads and NCWMS. We can switch around through time, and then we can switch our color mappings, all of the basic things that you'd expect from a WMS. Yeah, that's pretty much it so far. And then on top of that, we have Xpublish is a fast API implementation. So you have this full list of all your available API points in here to take a look into. And you'll see you have the Zarr endpoint, so you can load in this data set directly through here. If you don't want to go through and download the Kerchunk libraries or anything, you can just load it in. You can load our best time series aggregations directly from here, which is really cool. That's pretty much it for now.
Okay.
Yeah.
Awesome. Thank you.
Yeah.
All right. I'm going to stop the recording.